Hopefully I'll write my own one day that nobody will use. You can read my random thoughts at Julian Gindi. I hope you guys follow me. It's not really that interesting. And then you can email me, julian@isl.co. I love getting emails. That's a total lie. But if you give me an email with a question, I'm more than happy to answer it. I'm more than happy to continue this conversation because obviously I can't present enough information to tell you how to access whether applications to 1 million users. Hopefully we just learn how to get close. So this top bar right here is really bothering me, so I'm going to try to deal with that very closely. What is this?
Closing the tabs.
Really? Whoops.
Present presenters move, I think.
You know what? Whatever. I don't think Okay. So first thing I want to do is there's a quick poll that I put together. If you would all plug your cell phones, computers, or whatever, go to this link and vote on the poll. I want to get a baseline sense for how people scale their Django applications, how they set up their server infrastructure, and we're going to view those results and go from there. I'll wait a couple minutes until I reveal the results. Just 20 more seconds. All right. So honestly, these results were a lot more promising than I anticipated. The fact that we have 3 people using a highly modern system is really badass. Good work. Good work. And the fact that we have the majority of people using a clustered approach is another amazing thing. So kind of the main takeaway of this talk is about switching to this approach. So for the 5 people who voted that they use a traditional server, I understand. That's where most of us start. That's also how Django has been traditionally developed. So there's nothing wrong with that, but hopefully some of the lessons that I introduced, which were lessons from my own experience scaling our largest application as a company, will convince you to maybe switch over to the second approach. And for those people who are in the clustered approach, switch over to the modern approach is not as necessary as 1 or 2, but hopefully something that you become interested in. So I want to present the contract for tonight. This is what I hope to achieve. This is what I kind of set out to achieve. You're going to leave a better understanding how to build Django projects with scaling in mind. A lot of people think about scaling as an afterthought. Scaling should be something that you think of day 1. Now, over-optimization is a different story, which we'll talk about. But building your applications for scale is a big part of building Django applications these days. So I hope to teach you some basic fundamental rules about how to scale an application. Seems like a lot of you already know these, but for the people who do not, maybe some of these will be new to you. Maybe for the people who have a little bit more experience, you might not know all of these, and maybe they'll act as just a well-due refresher. And finally, I hope to teach you about a couple tools that I use that maybe you'll feel empowered to use and feel inspired to use. Now, like I mentioned, there's going to be a couple of scenarios that I want to present, and I want to get feedback on those scenarios. How would you solve this problem? Now, I do not want to be the type of person who has the right answer, because I don't have the right answer. A lot of you might have the right answer, though. So tell me how you do it, and I hope to learn as much as I hope to teach. So basic roadmap of what we're going to cover, concepts, overall philosophy, high-level stuff. We're going to talk about scaling Django. We're going to talk about scaling the individual server. That includes the web server, whatnot. And then we're going to talk about scaling the cluster, which for the people who do not have the cluster yet, hopefully by the time we get there, you'll understand why you should have one, and hopefully I'll present some steps of how to get there. So before we go any further though, I want you to meet Rhino, our trusted scaling companion. So he is going to act as a final arbiter for all scaling needs. So I'm going to present some scenarios, and then he is going to give us the right answer. So if he ever says something, you know it's right. You know he knows what's up because he has scaled a lot of applications. All right, so first, high-level concepts. 12-factor app. So who of you know what the 12-factor app is? Cool. Who can give me a brief overview of what the 12-factor app is without actually talking about any of the 12 factors? Remember that awkward silence? It's going to happen. It's going to happen until somebody speaks. I can also have a more awkward pose if you want. Yes, sir.
It's a paradigm in which you build applications so that you can horizontally scale them.
Couldn't really hear that. You want to louder?
It's a paradigm in which you build applications so that horizontal scalability comes with ease.
Exactly. Yeah, that's exactly right. First of all, 12factor.net. Read it. Honestly, read it. Heroku came up with these 12 concepts of how to build a highly available, highly scalable application, and presented them all. It's kind of the baseline for how Heroku works as a service. And a lot of these things, if you deploy and scale with Heroku, you'll have run into a lot of these things while you're developing your application. So regardless of if you adopt all 12 of these, it's a good thing to read to kind of see how somebody like Heroku is handling application deployment, and see kind of a little checklist of how close are you to a system that can just scale relatively infinitely. So a very quick summary of some of the 12 factors. As you can tell, there's not 12 here. There's a lot more that I'm going to discuss actually. But as Joseph Abrams over there mentioned, that the 12-factor app is a way to build systems that can scale horizontally. And one of those that we'll get to is stateless servers. Do not worry about that right now. But your application should be bundled with all the information that the system needs to handle your dependencies. So explicitly declare and isolate dependencies. If you deploy an application here, you deploy an application here, it should contain all that server needs to know to install those dependencies or utilize them. Configuration. All configuration should be removed from the code base and put into environment variables. So, real life example from my own experience in scaling an application. In our settings, Django settings file, we have allowed hosts, as many of you are probably familiar with. Now, to change the allowed hosts on our production server, we had to put it into our next server. We had to then let that go through the CI, we had to let that deploy, we had to kind of make sure that worked, even though it didn't really have any bearing on the next server at all. We needed to go into staging. Once you put settings like that into your code base, it's a world of error. Now, on production, I could have just changed that environment variable to say allowed hosts now equal this. It wouldn't affect any other environment variables. It wouldn't affect any other environments in general, and allows switching these things out a lot better. That, I think, relates very closely to backing services. All your backing services, whether it's a database, Redis, a queue, etc., treat them as attached resources. Change them with environment variables. So we use AWS for all of our web infrastructure. A lot of the things that I'll announce and present will have AWS terms associated with them, but I try to make the concept as generic as possible. So we're using Postgres through Amazon's RDS service. What if for one reason we decided that we wanted to host our own Postgres instance? How do we modify that? Well, we've set it up in a way that all we need to do is change one environment variable on an environment, and now we have a new backup service. So it allows those things to be a lot more modular, a lot more replaceable. So a lot of these things are using the process model, run an app as one of more stateless processes, which we'll get to. Port binding is kind of related to backing services. One of the ones that I want to highlight, but I'm not going to really get into too much, is the dev prod parity. I know it's deep down here right now. As best as possible, make your development, your staging, and your production environments as close as possible. So when a developer is working on the application, there's really no surprises when you get to production. So the way we do that is by simulating our production infrastructure essentially one-to-one using virtual machines. So we use a tool called Vagrant to do that. We have a configuration file. We save Vagrant up. It spins up a Postgres server, it spins up a Python server, it spins up a whole build system, and it mimics how we do things in a production environment. So there's really no surprises at the app level. We let application developers work in that realm, and then by the time it gets to me, who handles the infrastructure, there's no surprises and it works seamlessly. So I'm going to present the first of many example scenarios, and for people who might be in the same scenario, I'm curious to hear your feedback. For people who have solved this problem, I'm curious to hear your feedback as well. So, example scenario, we have a single server running our Django application. So we save all of our images, all of our user uploads to that individual server. So think old school Django. And you get hit with a ton of traffic. What do you do? Yes?
Well, assuming your traffic is coming because of the images and user uploads, you could put them on Amazon or something in order to catch them. So they wouldn't run
Okay, great. So that's a great first step. We realize that we're getting a lot of traffic that corresponds to our image and user uploads. We move those to a service like Amazon S3, which is a very highly sophisticated key value storage. So we can put those images off that server. Great, but we haven't dealt with traffic.
Spin up another.
Spin up another, right. So if we combine that with moving our images and user uploads off of the server, spinning up another is not a big deal anymore because we don't have to share those resources anymore. We can just point both of those servers at that shared pool of image uploads and whatnot. Yes, exactly. So, first lesson is stateless servers. Do this. Do this. Don't even think about storing stuff on your server. This is, I would say, the most important thing I'll tell you today is that if you have stuff on your server that the application needs to know about, you're screwed. You're screwed. Because you can't scale. Now, if we go back to the scenario, one of the options that I was hoping somebody would say is get a server that has more resources. Okay, yes, that would accommodate X more requests, but you're not going to be able to scale efficiently, and to scale efficiently, you need to scale horizontally. Now, scaling vertically is not always a bad option. I'll get to that in a moment. But don't store individual stuff that needs to be shared on your server. So why is that a good idea? Vertical scaling, not a good long-term solution. It is a good long-term solution when you need more resources. So let's say you're building like an image processing site. It has a lot of CPU usage and you're running an Amazon small instance or whatnot. Yes, you're going to want to increase the size of those images to increase the resource that you're limited in. But that's not really going to handle more requests. Handling more requests, there needs to be more what I like to call workers. And scaling vertically does not grant you more workers. The other thing is you get redundancy. Now, if you have 2 or more servers, one of them dies, who cares? There's another server that is totally fine running. If you have that one server in a very classical, traditional Django setup, you're screwed. If that server goes down, there's nothing you can do about it because you have valuable information stored on that server. So state is your worst enemy. When you're developing, you want to feel comfortable killing any server in your cluster. Not all of them, but you want to be able to kill a server and not worry at all. That is where you want to get. That is a baseline where you want to get with your infrastructure. It gives you freedom to deploy your applications in multiple environments, in multiple cloud providers, however you want to provide it. If your app is stateless, and even more so if it follows the 12-factor rules, you can deploy it anywhere. And containers, a little bit of the future here, so the 3 of you who voted that you're using a modern infrastructure, you need stateless servers for containers because containers enforces a service-based architecture. We'll talk about a little bit more of that, but you will need to get stateless before you can get to containers. And containers is, the Eden miles down the road. So one day. So cluster is your friend. A basic cluster, we're going to talk about clusters a little bit more later, but a basic cluster looks like a load balancer. A load balancer is just a server that accepts requests and sends those requests to the server based on a number of variables. We're going to treat this as a black box. All you know is that a request comes in and it goes out to a server in an opportune manner. And so you see 2 Django servers running here. Well, if one of those dies all of a sudden, you're not going to get a call at 4 a.m. in the morning. You're going to get no calls. You're going to, maybe you'll be aware of it. Maybe you'll have auto scaling set up, again, coming later, but you won't have to sweat as much. That also goes to the point where you should be killing your servers a lot. You should see what happens if one of these servers just flat out dies. So, going back to a previous idea that I had is making your applications as service-based as possible allows you to scale more effectively. So when you're developing your applications, think about the Unix philosophy. You want small, sharp tools, tools that do one thing very well. Now, if your application is monolithic and has a lot of different services that it needs to accomplish its common goal, maybe that's an opportunity for you to split some of those services out of that monolithic app and implement them in a language more suited for that task, and just put them on a machine that has the resources optimized to handle that task. So vertical scaling there might be appropriate. Going back to the 12-factor app, all additional components should be treated as attached resources. So I don't want to see any databases running on the same server as the Python application. That's just a recipe, a disaster waiting to happen. And once you have a more service-based architecture, you can distribute and schedule services based on the available resources and their own resource needs. All right, so now we're going to get into how to actually deal with scaling the individual Django application. So as I presented earlier, there's 3 arenas to think about scaling: application, server, cluster. Now, I would say the application is the first line of defense for optimizations. If your application is designed poorly, if it's implemented poorly, you're going to be dealing with scaling constantly, because you can throw as many servers at it, but there's something more fundamental there. So hopefully we'll address some of this. So the basics of optimizing Django. Beware of premature optimization. So you can start your application, basic stuff, all the functionality is done, and then you can realize, well, what else do I have to do? I'm going to optimize. Bad idea. Use data-driven optimizations. What this is listening to your servers, listening to your application through one or more methods, and realize this is the part that is causing me issues. The database is the issue that I'm experiencing most often. Once you have that clear data to tell you where to optimize, then you optimize. Don't just think about like, oh, we're going to be handling a lot of images. We should probably route those through a third-party service, then crunch them in a service-based architecture running Docker, then upload those to S3. We have a listener queue there. Yes, maybe it'll rock, but is that even your bottleneck? I don't know. So think about that first before you over-engineer something. I love the 80-20 rule. I mentioned it a million times. I talk about it all the time. Do the 20% work, that'll get you 80% of the way. And that's kind of what this whole talk is about, giving you those high-level things that'll help you progress to 80%. Now, once you're at 80% and you're around 500K users, the rest is a lot of technical jargon, and it's really beyond the scope of this. This talk is to get you to that 80%. As I mentioned, think about scale early on. And a great quote, I've kind of butchered this a little bit, and I believe that it's, who said this? Rattle off the co-creators of Go language and Unix. Steve Ritchie. Anyway, somebody said brute force is usually the most performant option when n is small. I agree with that 100%. A lot of the times, Rob Pike said that, by the way. And this kind of goes with the first point, be aware of premature optimizations. A lot of the times you'll look at code and you'll realize, oh, this is not the most elegant algorithm to use. Who cares if it's performant at the level of input that you're getting? That's not your issue. So keep that in mind. So application monitoring. First thing you're going to want to do. There's a couple tools to use this. To do this, New Relic is an amazing tool to use. Now it's not open source, it's not super awesome in that regards, and it is very expensive. But the free tier is immensely helpful out of the box. You don't need to pay a dime to get a lot of benefit out of New Relic. So think about using that. The Django debug toolbar. I'm also going to go into some of these in future slides. The Django debug toolbar is something that we have enabled in our virtual environments as well as in our development environment, which is a public-facing link. And this allows you to really get fine-grained details over your requests, template loading, resource usage, all of those things. So you'll see a screenshot of that soon. And then there's ways to just profile Django and see these are the commands that are being run, these are how many cycles that are being run through each command, time, etc. These are invaluable to figure out where your real bottlenecks lie. This is how you develop Django, data-driven Django scaling. So here's the Django debug toolbar on a screen talking about SQL queries. SQL queries are notorious for being one of the biggest bottlenecks in your Django application development. So you see here, here's a query that takes 1.71 milliseconds. None of these are very explicitly poor, but maybe you see one that says 3 seconds here. Well, there you go. There's your answer. Figure out what is causing that and fix it. I'll offer a little bit of a solution shortly. And as you can see here, you can see headers, requests, templates, static files. They give you a wealth of information that you can parse through and really drill down and figure out what is causing the lag in your application and whatnot. So again, finding bottlenecks. This is New Relic's Thread Profiler, but there's a lot of open source alternatives that will give you this exact view. It shows you a stack trace and it tells you how long the process is spending on each one of these lines of code, for example. Now, I realized that our load page, our home page, was taking a long time to load, something that I was not happy with. A fellow colleague of mine likes to use the term butter to explain how an application feels. If it feels like butter, you're doing well. If it doesn't feel like butter, that's not good. So always in the pursuit of butter, think about that. So the home page of our application was not really buttery, and so I wanted to figure out why. So I went through this, yes, the whiskey process is taking up 98% of the time. Well, I expect that to happen. That's really, yes. But then going down here, 59% happened in this Django template tag here. And I was like, what the hell is happening? Well, a lot of things are happening, some of them which I will go into more details, but basically it was loading this asset manifest file. We have a very robust build system, and so we basically dynamically generate that asset manifest based on the build environment. And we realized that loading that file, parsing that file, and then using that to load our assets was taking a shit ton of time. So there we go. First step how to optimize was, let's figure out what's going on there, and let's fix it. So, boom. The scaling Rhino has a tip for us. Beware of out-of-control queries. So here's some code. This is bad, as you can tell by this comment. So this is a very selfish function that I wrote, check for me. We're grabbing all the users. First of all, this code may or may not actually work, but you get the point. It's gonna, it's still correct. So I'm grabbing all the users who are developers. We're looping over each user. So this is going to execute a DB query for each iteration. So I'm saying profile equals element.profile. That's what's triggering that external query. That is a join database. So profile is a many-to-many relationship, let's say, one-to-many relationship. But each iteration through it, we're querying the database for that information. So we're checking if the real name is me, return true, return false. Now, this could be something that is causing you a lot of issues. These are littered throughout our code base that we've been trying to fix. And they might be littered in yours too. The easiest way to deal with this is to realize that the filter and most Django model operations are actually lazy. They're not evaluating this query until you ask for real resources with those elements. So we're going to grab the same query as before. Now that does not actually manifest itself, as I mentioned. And what we're going to do is called select related. So this is going to do a little bit of processing up front to grab those users but also grab those related profiles. So that query is a little bit more optimized than looping through each one. Now, when I do the same loop, it doesn't make an external database query each iteration through the loop. So already, that's a big performance increase. So the scaling Rhino has another tip for us. Learn to love caching. So here's the solution to that asset manifest problem that we had. We realized that it was parsing a YAML file every time we would make
Yeah, YAML.
Well, YAML. So here's a little basic example of what we were doing before. All the cache stuff was removed. We were grabbing the manifest file, we were parsing the manifest file, and then we were returning the manifest file. That was extremely intensive. So we had a very naive solution, let's just cache it. So we're getting that cache. If the cache doesn't exist, we're going to set the cache, cache.set. We're setting about a day to expire because we know it's not going to really change that often, except on deployments when we manually invalidate it. Different subject altogether. We'll return it. Else, return cached. This just squashed that performance issue. Done. There is some overhead in communicating with our cache. We're using memcached hosted by AWS. A little bit of overhead there, but nothing in comparison to the load that we had before. So again, simple solutions to big problems that we were having. All right, so here's another scenario. Yes, you guys are going to need to pitch in for this. Let's say each time a new user creates an account, there's an expensive API call. It needs to hit an API to validate some sort of aspect of that user. It's taking a lot of time. It's not butter. Users are not loving it. How do we fix that?
Make the call asynchronous. Have the user come back and deal with it later.
Okay, yeah. So make the call asynchronous, have the user come back and deal with it later. So I agree with all that. I don't really care if the user comes back and deals with it. I'll deal with it for them. But yes, in a sense, you were right. Celery is badass. So Celery is a kind of a background task runner. It allows you to specify tasks that you can call with your Django application that get routed out to Redis, Memcache, a number of different backing services, execute those tasks. You can then query the result of those tasks, and if the query says, oh, we're good, we got the result, then you can grab the information from that. So here's a very basic background task here, importing requests, and all you have to do is include this little decorator on a task. There's a lot more setup that needs to be done, but in terms of the actual time needed to implement Celery, is really not that significant. So we're saying API call, URL, method. If the method is get, we're just going to grab it and return it. So now that is a bottleneck removed. We say, here's an expensive task, let's put it in the background. We don't need it on user creation. We don't need it until a user profile is accessed God knows when. So this is a appropriate use for it. So Celery, badass, use it. All right. How much time do I have? Oh, I'm running late. All right. We'll try to get through all this stuff. Kicking things into high gear. UWSGI and Nginx. A love story. So we've been using UWSGI and Nginx together, and it's been extraordinarily awesome. Initially, it was not as awesome as I thought because we were not doing it correctly. I realized how we could have improved that, and so now we're screaming. And hopefully I'll tell you kind of what I ran into and how to deal with that. So why did we choose UWSGI? It's fast. If we set it up and do nothing about it, it's fast. There's debates whether it's faster than Green Unicorn, but whatever, that's beyond the point. The other things are what I found to be more compelling reasons to use it. It speaks many different protocols. So we're using the Unix sockets plus WSGI to communicate from UWSGI to our application. But if you're using a Ruby application, if you're using anything, theoretically we can still use UWSGI. It's called UWSGI because WSGI was the first protocol it implemented. But now we have this web server that we can theoretically use for multiple different stacks. So that's a good thing. It's highly scalable. It comes out of the box with two awesome modes, Zerk mode and cheat mode. Zerk mode allows you to set a worker pool. UWSGI uses workers as a representation for the number of instances of your Django app that are running that can all handle requests. Zerg mode says here are 50 workers that are sitting doing nothing, and you can grab from them as you need. Cheat mode is something that we used before. We don't use right now, but it's still something to think about. You set kind of a base level for how many workers are always active, and then they will add on workers as requests come in. Similar to Zerg mode, but a little bit more methodical. You can say, every time we hit that threshold of needing more requests, we'll get 2 more workers. I'll show you an example of this. It's very highly configurable. It's very good for system administrators, and it allows you to really have fine-grained control over every aspect of the process. And it has a great article called The Art of Graceful Reloading that says your apps are going to be reloading all the time. What are you going to do with those requests that are actively engaged? Are you just going to drop them and hope that they refresh the page, or are you going to handle them with a new process? So WSGI is very optimized for handling graceful reloading, and it has a whole article dedicated to the topic. So here's an example config, partially taken from what we use ourselves. So as you can see here, we're defining the WSGI process. We're specifying that we want to use sockets. Here's the WSGI module. Here's the PID file. The PID file allows you to kind of interact with this process as a more traditional Unix process. We're setting the home. We're using virtual env. If you're not using virtual env, I don't think anybody is in that boat, but if you are, use it. Some of these are not as important. We're using threads, single interpreter. But here's the magic. So this is using cheaper mode. So we're using, there's a lot of different cheaper algorithms that you can pick based on your individual scaling needs. We're using spare. Basically, if a request hits a certain threshold, we're going to bring on any spare workers that we have. So we're starting with 2 workers. We're going to scale up to a maximum of 10 workers. And then each step is going to be 2 workers. So fairly basic, but just an example of what a WSGI config looks like. It's pretty readable, pretty easy to set up. So using WSGI and Nginx together is awesome because they could speak the same language. A lot of people will use Nginx passing those requests through HTTP. Not the most effective way of doing it. So what we do is we have an upstream of Django listening on a socket, and then any traffic that is non-media requests are going to go to our Django server. So we're saying, oh, the location is WSGI. We're passing it to Django. We're including these additional parameters, and now we're rocking. This single-handedly increased our performance by a number that I don't actually have, but a lot. It really had a big impact. We were going from HTTP to sockets, and so that was a big impact. But then we went from Nginx and WSGI talking over the WSGI protocol, and that was huge. So if you're using WSGI and Nginx, do this. It's also not that hard to implement. So, scenario. You notice a number of connections are erroring out and not being handled. What do you do? And warning, this is going to be the most technical part of the talk. So if you don't have the answer, this will be the only one that I'll just move on from. Okay, I'm going to
Start looking for a new job.
Yes. So this is the solution that we found. 2 things at the OS level. Maximum files open, and the OS limits for simultaneous connections. So the reason that we ran the file limit is because each socket connection is a file. If you're familiar with Unix, everything is implemented as files. And so the max was set at a lot lower of a rate than we wanted, and now we knew that this server was only going to be handling requests, so we found a level that made sense. So I edited etc sysctl.conf, and I made it 70,000. I don't know if that's a good idea or not, but so far it's been, working. Also, WSGI has a number of processes, so 2 to many, and each one of those processes has a queue associated with it. So if more connections are forming that can be handled, there's a queue that happens. Now, the operating system limits you to 128 people in that queue. So that means anything above 128 per worker is going to just be thrown away. I don't like that. So I modified this file, I increased that to 2,000, and then you also can specify a setting in WSGI that says each person should have a listen queue of 2,000. Now, typically you want to do that in conjunction with a proxy timeout. If your process is just timing out, you don't really want to keep those people waiting. You want to move them into a new process. But if that process is just chugging and churning and doing what it should be, yes, maybe you do want to keep a connection. All right, so the final part is scaling at the cluster level. So these are the main steps to ensuring a highly scalable application. Use a load balancer. Utilize auto-scaling. Kill servers randomly. I mentioned this before. Make sure you can handle those ephemeral servers, no state. Rethink your deployment system. Oh, look, it's a Rhino, the scaling companion. So you better be using a load balancer. So load balancers are awesome. Again, think of them as a black box that you send requests to, and then they allocate those requests in the most efficient manner. But they do a little bit more cool things. You can utilize what's called health checks. So each one of our servers knows how to respond to a health check. That could be as simple as /health, returning a success code. It could be a process that runs. But if that server does not meet that or succeed in that health check, kill it. So I say kill unhealthy servers quickly. Theoretically, if you have stateless servers set up, you can just replace it very quickly. So you're kind of moving away from highly tuned servers to a little bit more stupid servers that are dying quicker and being spun up more quickly. So also it spreads the load across many servers in different availability zones. So this again is an AWS specific idea, but availability zones are just different data centers. And so we could have data center A, data center B, hurricane comes, wipes out data center B, I don't care, because data center A is still running. So make sure you do that. Not only is it going to distribute load more effectively, it's also going to make your service more available, which is what you want. For any, yes?
How does session tracking get handled?
Good point. So we handle sessions using Memcache. All of our instances talk to the same Memcache instance. So far that has been all that we've needed to do to handle that. All right, another tip. You better be using auto-scaling. So again, AWS concept, but a lot of other cloud providers provide the same functionality. And if they don't, it will take some time to implement this, but it's relatively straightforward on how to do this. There's a lot of paradigms out there to help you do this. So this allows you to scale based on resource needs. So if we say, oh, our max CPU is topping out at 75%, we need to spin up 2 more instances. It allows you to do that. So one thing to note though, this is not possible without stateless servers. So again, harping on that individual point. You can also auto-scale based on times of day. So let's say we know that a bunch of people are using our application at 7 p.m. We can preempt that by spinning up 3 more servers at 6 o'clock. So things like that are just immensely useful and just really awesome. All right, so deployments. When you switch to a cluster approach using auto-scaling, you need to rethink your deployments. So traditionally, what you would do is you would get a new server, you would probably kiss it maybe, and then you would install all the dependencies on it using configuration management, hopefully. The server would take a while to get ready to handle requests. Maybe you're tinkering a lot with that server, maybe you're making sure it's ready to handle requests. It's a little bit too much love. A little bit, yeah, you don't really need to be doing that. Your servers should not be loved by you. They should be killed very easily. So what you want to move towards is pre-built images that already contain all of those dependencies, and the only thing that's new is the actual code. So what you would do is you would deploy to this image that knows how to run the application already. You'd throw it in there. Maybe you would divert a segment of the traffic to it. Maybe you'd divert all the traffic to it. But if everything seemed to work successfully, if it passed the health checks, etc., you know it's good. So that's called canary deployment. If it's all good, the image is basically compiled, so now you can deploy 1 or more servers that already have the code ready to go. So that means if you have a system that is stable and a server dies, you already have a new server ready to go with all the code needed to continue. So that's a really big paradigm shift. It's not easy to implement, but it will just drastically change how you do deployments and how you deal with your highly available services. So one last thing, load test early and often. So you're not going to really know how your application can handle concurrent requests, many requests, even using services that do load testing, it's not 100% accurate, but at least it provides a benchmark. So I use something called loader.io. It's very easy to set up. You just put the domain in there. You can specify subdomains, individual aspects that need to be requested and whatnot, and you get and you can specify how the traffic is handled. You can set at the end of a minute, I want 10,000 requests, and so it'll ramp it up. Or you can say I want 10,000 requests simultaneously handled each second, so 10,000 new a second. A ton of crazy ways to do it. Again, this requires kind of a more scientific approach. You run a test, you have a hypothesis, you make changes, you rerun the tests. It's very scientific. And so this is an example of one of our early load tests. You can see that average time to load increases as requests load. Pretty standard. That's basically what you're going to get. But once we hit a certain threshold, time was increasing a lot. And once we actually hit this threshold, time was dropping a lot, which actually represented drop connections. And as you can see here, another load test had our response time dropping to 0, which meant those requests were just dying. So these are all things that I use to feed my data-driven optimizations. And so I realized, requests are just dying once we get to a certain threshold. That became the lens in which I looked at scaling the application. I was able to isolate that and fix it. If you're just approaching your whole thing as, how can I make this scale, that's not going to work. You need evidence. All right, so that's a wrap. Any questions? Yes, sir.
Have you tried to use the Docker in production?
Very interesting, yes. So not yet. All right, we plan on doing it, hopefully one day. But Docker is awesome. It allows you to specify resource constraints on your applications. It forces a more service-based oriented approach. You can also use it in conjunction with things like CoreOS that allow you to kind of remove a lot of these traditional issues that you run into, kind of just deploy your applications in containers and not really worry about how they're allocated. Computers are really good at a lot of things. Allocating applications based on their resource need is one of them. So no, we have not done it in production yet, but hopefully we will soon. We've identified it as as a major frontier that we want to get started with.
I want to try to.
Yeah, it's cool. Yes. It's called loader.io. There's a lot of them out there. There's open source ones. This is a paid service. It has a free tier that we found pretty sufficient. So yeah, that's what I use, but a lot of stuff out there. Bees with machine guns is another good one. That's a Python-based one. That's open source. That's pretty cool. Yeah.
How do you handle the migrations? Migrations, would you add any field to the...
Great question, great question. So migrations is the issue. Migrations is an issue that everybody really has issues with because it kind of puts a kink in your auto scaling and whatnot. What if your new code needs to modify the database? How do you test that? I'll give you the honest truth. We don't know yet. We don't know yet. So we're trying to figure out the best way to do it. There's ways to use temporary databases, make sure the application still runs with that, run some manual tests on that, and if that's the case, bring over the new servers, run the migrations, everything should be fine. But it seems like in the immense amount of research that I've done on how to really bring our company and our projects to this more auto-scaled, more clustered-based approach, it seems like all the companies' migrations are the difficult thing to deal with. So a lot of people, what they'll do, and what we're doing right now, is we will attempt to use the more modern deployment approach for code that does not have migration changes, and for code that does have migration changes, hopefully that's caught during a staging deployment or development deployment. If not, we'll do a little bit more of a traditional deployment.
Do you use or would you recommend multiple load balancers for a single app?
That's a very interesting question. Honestly, I have not encountered a scenario that has seemed like a great option. So I can't really attest to that, but good question. I'm going to do some more research. Yes.
How do you handle environment level configuration changes or new services that you add?
Yes. So I guess the way we do that is, so for example, on our virtual machines, we use Whoosh as our search provider, but we use Elasticsearch for our more production-ready services. So now, going back to the 12-factor app, everything is treated exactly the same, whether it's a local file system search or it's a multi-machine cluster. All it is a one environment variable change. And so that's one of the first reasons why we like port binding our services as well as using environment variables. It doesn't matter who those services are. We just replace those variables. Does that answer that question? Cool. Yes, sir.
How do you handle debugging when you're putting all of your settings in environment variables?
That's a good question. So the way we do our environment variables is we use Fabric to control our servers. We kind of have a nice API wrapper using Fabric. And so at any point we can get a dump of all the environment variables that we are manually setting on an individual server. So let's say we ran into an issue. We had two identical code bases, staging, production, and we could not figure out what the differences were. Well, typically those scenarios don't arise because we try to make those environments as close as possible. But if there was a discrepancy, we'd be able to see that very quickly based on getting those environment variables, looking at the service that we're using. But a lot of it just boils down to the dev production parity. Trying to get those environments as close as possible is something that we've actually been pretty good at. And so we haven't really seen those differences from environment to environment.
But if you're killing all your servers quickly, are you monitoring at the same time? Like
So,
pulling those environment variables at a regular interval?
well, the environment variables are kind of fixed. So production will always have the same set of environment variables no matter how many servers they have. So if we do kill a server, though, New Relic typically, there is a section in New Relic that says deployment. And so you can see when you deploy new code, how are your resources kind of handling to that new code and kind of make decisions based on that.
How do you scale the data by server?
So we actually kind of took a cop out there. We're using Amazon RDS. And with a click of a button, we get two awesome features. One of them, we get what I call hot standby. So it's a different database server that has the same copy of all the data and a different availability zone. So if our main database server goes down, boom, we have a new copy of it. You can also do what's called read replicas, which are servers that get all of the same data as your main server and are read-only databases. So you'll write to the main database, it'll propagate those changes to read-only databases. So being an Amazon service, it's infinitely scalable. So it's just something that we don't really have to deal with. But we do have a little bit of experience scaling Mongo. And we use techniques like sharding to help out with that. And we use read replicas as well for that. But we like to scale, in an ideal world, we will only scale application servers and leave the scaling of the stateful stuff to a service that definitely knows more about it than I do.
Last call?
You seem like someone who's very interested in getting pages to load very quickly. When are you satisfied with knowing that your application is performing at a good level?
Never. That's the issue, is that, and that's why I brought up the 80-20 rule, is that I could be at this all day, and I could just really tweak everything for what it's worth. But we are a client services business, and so the client usually has a very clear picture of where this application is going to go. And I try to ask them as much as possible, in your wildest of dreams, what is the traffic that this site's going to get? Now, you would think that most people are going to say, billion users tomorrow, but they don't usually say that. They say something like 10,000 users, and I'm like, well, shit, that's manageable. So, to your first point, no. But to your second point, I realized that there's a lot of stuff that I have to do in a given day, and so once I reach the threshold, and hopefully exceed it a little bit, what the client wants, then I know I'm in a good position. It's a little bit easier than other people, but I challenge you, if you're developing your own application, think about realistically, what does your traffic look like in a year, 2 years, and again, if you think about scaling early, the changes between 10,000 users and 100,000 users are going to be more tweaks than major overhauls. So, but I have seen too many a company scale from 1,000 users to 100,000 users and have to redo everything. So that's really not the situation you want to be in.
When you're sort of moving toward more of a service-based architecture, how do you deal with a local development setup that now involves 20-some virtual boxes?
So, something that we are wrestling with right now. There's two ways that we're dealing with it right now. Using Vagrant, you have your Vagrant file, and you can specify all the resources that you need. So database server, build server, Python server. That's kind of what our main development environment looks like right now. And as I mentioned, we're using local search on our actual development machines because the interface, thanks to Django, is the same. But what we're looking into right now is using Docker Compose, which allows you to specify all of the services that you'd be using in a YAML file. Funny that I mentioned YAML now. But so you can do Docker Compose up, and it'll spin up a container running all of these services that are already connected via ports. There's Etsy host entries already, all handled for you. So you can have a very highly distributed service spun up on your local machine within seconds. So that's something that we're looking into.
I use it. We use it in a project we're working on, and it's, I don't know if it's quite ready for production, but it's super promising. It's a little glitchy.
Well, you don't need it for production, actually.
Yeah.
For me, it's Docker Compose is really only a local development thing.
Sure.
When I'm using those same containers on a production level, I don't think I would use that system.
Oh.
Yep.
How do you do your canary deploys?
So we are actually looking for the best way to handle that right now. So there's kind of two main thoughts that I have right now. Using Ansible for deployments, you can kind of Ansible is really good at doing deployments. You can specify those health checks. You can specify those metrics to get information about those servers to see if they're successfully deployed. Another option we're looking at is a little bit vendor locked, but still a very good option, is using Amazon CodeDeploy. And Amazon CodeDeploy gives you 3 ways to deploy your new code. You can do it server by server, and if any server fails in that process, kills it and stops the deployment. You can do half and half. You deploy to half the servers. If those are all successful, you deploy to the other half. Or you can do all servers, which I don't really recommend. So 2 ways of looking into it. I also wrote it's on my GitHub page. It's not 100% finished. It's called Europa. It's a Python/Bodo based AMI deployment system. So we create a kind of compressed image and then use that to auto-scale our applications. But I don't have health checks built into that. So definitely something that we're looking into, but there's a number of ways to handle it. I'm just trying to fit it in with our old school deployment process while simultaneously trying to bring people to a more modern approach.
So your new process is going towards immutable images?
Yes.
Okay.
So we are at immutable images right now, but the actual deployment of immutable images and checking to make sure that deployment happens, so canary deployment, there's still a lot of room to figure out the best workflow for that.
Okay, let's give a hand to Julian. Thank you. Are you going to be at the bar, Julian?
Yes.
Okay, if you have more questions, you can find me there. I'll be there. If you go out the way you came in, then you can just keep going down this alley and then turn left, and we're going right proper brewing company. If you want to speak in June, come and talk to me or Chad. If you want to help us do an ambitious something for Django's birthday party in July, come and talk to me and Chad. Otherwise, I'll see you guys next month. Thanks.